Hello, and how you doing there, Dynamics nerds, people of all ages? Today, I'm going to be discussing one aspect of my everyday life, and that is Dungeons and Dragons, specifically the act of rolling dice. Rolling dice, as it turns out, is a lot more complicated than one might expect, dynamically speaking. First and foremost, looking at the shape of the dice. Most common dice rolls involve what's known as a d20, or a 20-sided dice. In this sense, they're neither spherical nor a perfect cube. When I was first thinking about doing calculations involving the moment of inertia of a d20, I thought I could start with the moment of inertia of a cube and then cut away small triangles until I was left with a d20. But as it turns out, that's a little more complicated than I anticipated. Yes, all of the triangles are equilateral, but knowing the exact angles of the 3D triangles that I would need to cut away, it starts getting a little more complex. And I thought, maybe since these are rolling objects, if you're using one that's small enough, you can use a sphere to approximate, and you'll more or less be in the ballpark. Another facet of this is bounce. A lot of the times when you roll a dice, it bounces off of whatever surface you're rolling it on. Some people make certain things to dampen bouncing, which in terms of dynamics would mean that they're trying to reduce their E value in their impacts, if you're looking at this from an impact momentum perspective. In this scenario, the lower the E, the better. If you're looking at things like sound or just better dice rolls, you want that low E so the dice is kind of in the air as little as possible, so to speak. This actually yields some interesting things when the dice is rolling as opposed to bouncing, in that a lot of the times fabric is used to reduce an E value. But fabric, with the resins used, with the metals used, tends to have really low friction, which when rolling can lead to a lot of rolling with slip as opposed to without slip. If you're using a high impact surface like a wooden table, which I would not recommend for your dice rolling, you will get those very high E values with a lot of bounce because of your impact and momentum. But when the dice is rolling, it's a lot more dependable as far as frictional forces are concerned. With the low E values, you're getting a lot of sliding, a lot of friction with slip, and that can make calculating where a dice might end up a lot trickier. So there you have it. Looking at Dungeons & Dragons dice rolling through the lenses of a dynamic student. If you're curious, I worked out an example type problem, link in the description below. Until next time, good luck raiding the castle.